this is Galadrin and welcome to a new video of this channel. Today I'm gonna bring you another video on the universe that, as I was saying, is one of my favorite topics. And today's subject is quite interesting and it's about the shape and the structure of the universe. And I always been fascinated by this topic in particular, and I want to bring you the latest information and news that the scientists have gathered through observations and studies. So I hope that you enjoy the video, guys, and let's get started. The universe is huge, more than anything we can imagine. Since humanity has been aware of the immense space out of our world, curiosity has led people asking themselves more and more questions. Is the space infinite? Does it have a border or an edge? Is it possible to determine the structure or the shape of it? Difficult questions. But thanks to the enormous progress of technical instruments and observations since the 16th century, we have got some answer to some of them. We can start saying that in the universe there are different regions of space filled up with galaxies and stars. These regions are part of our reality as much as we are, even though we can never interact in real time with them due to the distance and the finite speed that light can reach. As discovered by Edwin Hubble in 1929, the universe is expanding, so all these regions with galaxies and stars are moving away from us, and some of them are disappearing from our visible horizon. This because they are probably moving away faster than the speed of light. For this reason, it's somewhat difficult to define the size of the entire universe due to the constant expansion and acceleration. But we can definitely define the size of our observable universe. In this stage, the normal units of measurements like kilometers or miles become incomprehensible. So scientists have adopted a new measure, the light year. A light year is the distance light would travel in 1 year. This would be 9.46 trillion kilometers. That is 9.46 per 10 to 12 kilometers. We can imagine the observable universe as a bubble, with us in the center, and the word observable does not refer to the capability of modern technology to detect light from a faraway object, but it refers to the physical limit created by the speed of light itself. In fact, no signal can travel faster than light, so any object moving away from us faster than the time needed by the light to travel back to us and show its image simply cannot be detected yet. According to the measurements, the proper distance between Earth and the edge until which we can see objects in the universe is 46 billion light years. This is the radius of the observable universe, making the diameter of the observable universe about 93 billion light years. Some estimates done when the universe began to inflate, plus adding its speed, suggest that the whole universe, if it is finite, might be more than 250 times larger than the observable universe. But there is much speculation on this number. The thing that we know for sure is that due to the expansion in some billion years, more and more objects will cross the visible horizon, and there will be a lower and lower number of things we could see. We don't have to make confusion with the number though. It is a common misconception to consider the size of the universe as 13.7 billion years, the same as its age. That would be correct in case there was no expansion. But seeing that it happens and it is still happening, the radius of the observable universe, as we said, is 46 billion light years and the diameter 93 billion light years. But how about the structure and the shape of the universe. Sky surveys and mapping of the various regions of space have determined that the structure follows a hierarchical model, with stars organized into galaxies, which in turn form galaxy groups, galaxy clusters, superclusters, and filaments, which are separated by immense voids, creating a vast foam-like structure, sometimes called the cosmic web. Regarding our galaxy, the Milky Way, it is inside the Fishes Cetus supercluster complex, a galaxy filament in which there is the Virgo supercluster, which in turn contain the local group, the galaxy cluster that includes our Milky Way. This whole thing is about 1 billion light years across. On a bigger scale, considering the universe as a three-dimensional environment, and considering the general relativity law stating that the space can be bent by mass, we have three geometrical hypotheses on the shape of the universe, and each of them implies a different past and future for the universe. First, a flat surface with zero curvature, where two hypothetical parallel lines will never cross. In this scenario, the universe can be infinite and slowly keep expanding forever. Second, a spherical surface with positive curvature. In this scenario, the universe is finite, and the expansion will eventually stop and turn into a contraction. Third, a saddle-shaped surface with negative curvature, with two parallel lines that will keep distancing from each other. In this scenario, the universe is infinite and will keep expanding forever. The current theoretical belief is that the universe is flat, according to observation of the curvature of the light in the cosmic microwave background radiation. But an interesting study that came up in 2019, based on the latest data from the Planck telescope currently in orbit, argues that the universe may curve around and close on itself like a sphere. This can be a possibility. In fact, the universe may appear flat to us only because we are in a region that has almost no curvature, like 99% flat, but inside an enormous spherical universe. Nowadays, we are considering that 1% as a possible calculation error, but the new theory considers it on the way around, saying that it is the proof of a slight curvature that may suggest the universe is a sphere. One thing is sure, we need more and more studies and observations to clear these points. But with always improving technologies and humanity approaching to be a multi-planet society, that might be possible.